In 2007, I had a neuroscientist on named Dr. Larry McCleary. He said that on this very show. He said, hey, in research circles, they're referring to Alzheimer's disease as type 3 diabetes. And I thought that was so brilliant at the time, but it's just now kind of getting into the mainstream vernacular.
Yeah, oh yeah, that's right. Now, full disclosure, I don't love the term type 3 diabetes. To me, that muddies the water and people think it's an entirely different disease. I think it's more accurate just to say it's insulin resistance of the brain, but that's splitting hairs.
Although, from a marketing standpoint, like
Oh,
your wife sick, it hammers home. Okay, it's not just old person's disease. It means there's something metabolically going on in the brain, just as there's something metabolically wrong with the pancreas for type 1 diabetes and with your metabolism with type 2 diabetes. I think it is a good term, in as much as I think people understand when you hear diabetes, it makes more sense to people. It gives them that sense of urgency, whereas insulin resistance of the brain, okay, whatever that means.
no, no, you're absolutely right. Yep. By a marketing standpoint or an awareness standpoint, it's much, much, much more compelling. So, this study was unique for my lab because it wasn't a basic research or an intervention study. Usually, what I do in my lab is we're growing cells or we have rodents and now more and more humans, and then we do something to the biomedical model, whatever it is. We treat the cells, we treat the rodents, we do something to the humans. This study was not. It was strictly an observational study where I had colleagues here on campus, and he is a bioinformatics guy. And basically what that means is he's a data miner. He has access to these massive databases of gene expression. And he was an Alzheimer's guy, so he was looking at different gene expression in the brains of people with Alzheimer's. And these were humans, of course. This is brain. You can't get brain tissues from humans until they're dead. So this is people who donated their tissues to science upon their death.
Yeah.
And he had access to these two groups, people who died without Alzheimer's and people who died with. And so I had just said to him one time, hey man, we gotta look at these glucose related genes and compare them with the ketolytic genes. And he was very enthusiastic because he had himself tried a ketogenic diet and loved it and experienced tremendous benefits. So that's the general study where we looked at all of the genes involved in glucose metabolism. That means glucose uptake. So the genes. So but maybe one step back, a gene is a recorded section of DNA, and then that little gene will then be converted, essentially translated into what would become a protein. And then that protein will go and actually do something throughout the body. So we looked at the genes that encoded proteins that are involved in the movement of glucose into the cell, glucose transporters, and then the catabolism of the glucose. So once the glucose is in, the genes that are involved in breaking down the glucose for energy. And we did this by looking at the hippocampus. The hippocampus, tucked deep within the brain, is the memory and learning center. That's the part of the brain that gets substantially compromised in Alzheimer's disease. So we looked at all the genes involved in glucose metabolism, and then we looked at all the genes involved in ketone metabolism, the uptake of ketones, and then the breakdown of the burning, if you will, of the ketones for energy. And in the brain, there are 4 distinct cell types in the hippocampus, and maybe I'll leave it at that. So the hippocampus is not just one homogeneous tissue. No tissue is. It's always a mix of various cells. The hippocampus has 4 key cells. We found that in all of those cells, I think it was virtually every single gene involved in glucose metabolism was significantly down, and a lot. It wasn't a subtle difference. So almost every gene involved in glucose metabolism across all of the cells of the hippocampus was significantly down. That was so relevant because it provides, let me come back to that idea in a moment. Then we looked at the ketone-related genes, and in one of the 4 cell types, some of the ketone genes were down. I think 2 or 3 of them were down, but then all the rest of the genes were normal, all the other 15 or so, and in the other 3 cell types, they were all normal. So essentially, the ketone genes were totally normal across the Alzheimer's hippocampus and the normal, healthy, non-Alzheimer's brains. Now, that was exciting because it provides for the first time a genetic foundation to what had already been seen at a physiological level. So you have scientists like Stephen Cunnane up at Sherbrooke University. He's one of the leading authorities on brain energy use. And he had found previously that in people with mild cognitive impairment and full-blown Alzheimer's disease, that as they measured glucose metabolism in the brain, they detected that in these cognitive impaired states, glucose uptake and glucose catabolism was significantly down, but ketone uptake and ketone catabolism was totally normal. So these two findings really complement one another, our genetic findings and then his physiological observations.
So is that an argument for trying to increase ketone production from an energy substrate to fuel the brain better? I'm just trying to
Yeah.
clarify practically what this means.
Oh, 100%. That is a clear takeaway for me. And when people were asking me about that, they'd always say, "All right, well, so what?" And I would say, "Well, there's a few so whats. One is that diet matters. That there's a clear lifestyle component to dementia, which in and of itself is novel, because the classic paradigm of Alzheimer's is you have an ApoE4 genotype and you're
Yes.
doomed because you're going to get plaques in your brain, you're going to get these
Yeah.
nerve tangles, and you're doomed. But the thing is, direct interventions in animal studies, and then a little bit of evidence in humans to try to attack the plaques or attack the tangles, they just don't really yield significant results. And so those classic ideas of Alzheimer's are kind of falling by the wayside. And then I think the metabolic origin is being picked up almost out of desperation. So my takeaway is it is a lifestyle related disease, not 100%. There's got to be some genetic predisposition. But even in people without ApoE4 genotype, you can still predict their Alzheimer's risk based on their insulin resistance and glucose control status. So there was a phenomenal study done in the 90s by a group in Finland that found that someone's fasting insulin had a more tightly correlated statistical value to Alzheimer's risk than their age. So fasting insulin appeared to matter more to Alzheimer's risk than age, which is just mind-blowing. But it just is reflective of how relevant metabolic health is. So the first takeaway was lifestyle matters, and the second takeaway is if lifestyle matters, well, then you can do something about it. And my big thing is keep your insulin low, because that'll help the brain be more insulin sensitive and then respond to glucose and take in glucose better. But then also, if you're insulin sensitive, you're going to have lower insulin and you're going to be making ketones more readily, and then the brain can be using the ketones as a fuel happily as well, which it does.
Hearing you talk about Alzheimer's disease in this way and how the old paradigm is being replaced with this new metabolic paradigm is very reminiscent of what's happening with cancer right now. And people like Tom Seyfried and the work that he's doing, he's been out there for a long time doing a lot of this same kind of research you're doing, except from a cancer perspective. Did they just like blow it, Ben? How did they miss this so badly that it's now going to have to uproot everything we thought we knew about both cancer and Alzheimer's disease?
Yeah, well said, Jimmy. That's a great way of framing it. So I think that we are remembering lessons of the past. By that I mean, I think 100 years ago, we were using diet to treat disorders that, like Alzheimer's or cognitive decline, and other brain disorders like seizures and migraines. Yep.
Yeah.
Yep. So now, however, I think those fell out of popularity because we got so clever and we started making all these sexy drugs. And so then the drug became the treatment of choice rather than a dietary intervention. And then with the ongoing, for lack of a better word, failure of the drugs, or an inability or a dissatisfaction with these drugs, I think there's been a rediscovery of the lessons of the past. You know, in our hubris, we thought we knew better than centuries old wisdom because we could make these clever drugs nowadays, only to learn that we had in fact not been solving the problem. And we go back to the old way of doing things, which is to change what's going in the body.
Yeah, and there's a lot of interests at play that want to keep the current paradigm going, and financial, and even like in the institutions that would publish your research. Which, by the way, has it been published yet in any journal?
Oh yeah, Yeah, my article was published in a very good journal, so I'm very pleased with how that turned out. It's a very high impact journal.
Well,
Well, yeah, the name of the journal is the Journal of Alzheimer's and Dementia. In fact, I actually paid extra so that it could be open access. That's an option that
oh,
authors have more and more. So it's open access. Anyone can go do it. If someone just goes to Google and types in Bikman and then ketolytic,
yeah.
that'll probably be the first hit, and you can click on it and read the whole study.
So those of you that don't know, full access, that's where you can print the whole study. And it's when I do my Jimmy Make Science Simple, I love when I can have an open access study because I
Oh
can
yeah.
read the whole and really dig deep into that. So I definitely encourage you guys, go download that study. And yes, Google makes it very easy to find those things. So how long was the study? How long did you take to do that one?
Yeah. So that was actually simpler than most because I would say from beginning to end, the study took about 5 months, and that was mostly just the analysis. These are such massive computers and massive databases that these computers just take time to get through. And then once we had the data, it was probably a couple months writing it, preparing it, and then of course the review process is always a painful process. That takes months.
So, Ben, would you say that your study now kind of sets a hypothesis for living humans dealing with dementia and Alzheimer's? And if so, I mean, you're obviously not cutting brains at that point, but how do you apply it other than, I guess, try the nutritional and other lifestyle interventions like exercise that could boost ketones, like exogenous ketones, like uh, MCT oil? We could go down the list of all the things that boost ketones. Is that what you're hoping happens from your study?
Yeah, without a doubt. That is an absolute hope that if I were talking to my dad and he said, "Oh boy, Ben, I'm really slipping. What should I do?" My immediate comment would be, "You got to up your ketones and lower your insulin." So I'm not generally a big advocate of exogenous ketones um,
Thank-
because I don't like the idea of chasing the ketone. That's not what it is about to me. It's about lowering the insulin and everything else that comes with that. But in this instance, I would say if someone does um, notice some genuine cognitive decline, and it's a subtle thing, it's hard to see in ourselves too. I kind of make the analogy of it's like when I was losing my hair in my mid 20s. I never knew how bald I was getting because I would just see little subtle changes every day. So it's hard to determine our own cognitive decline. But if we are able to get it, if we are able to detect it or have it objectively determined for us, then I would say that is the time to invest in some exogenous ketones because now, as much as you still want to keep the insulin low, and you do 100% want to do that,
yeah.
you now also are chasing the ketones. You want to make sure you are giving that hippocampus as much energy as it needs at any moment. And Jimmy, that matters. We have a bit of a side study we've been working on where we measure the metabolic rate of the hippocampus, which again is the memory and learning center, and we compare that with the metabolic rate of the hypothalamus and the thalamus, which are nearby brain structures, and the hippocampus has a much higher metabolic rate. So that little memory and learning center has a high metabolic demand. It needs to be fueled. And if there's any compromise in your glucose use at the hippocampus, well, then you sure as hell better make sure you got all the ketones the hippocampus needs to stay fueled.
So is there a target for the glucose ketone index, GKI, as the shorthand people might have heard, with this protocol that you think would be therapeutic?
That's a great question, and I don't have any idea.
I
No.
mean, objective lowest possible on glucose and highest possible on ketones, I
Yeah,
guess.
yeah.
And it would
Yeah,
be
and so for me, within reason, that's typically going to be a number less than one within reason.
yeah,
Like I
yes,
would say anywhere from around, if a person were wanting to do this, and I'm just pulling this out of my pocket, I'd say if
right.
you were hovering around zero point 0.5, that's probably going to be a pretty nice range.
Yes. And so for people that don't know, so you're translating glucose into millimole, and then
Yeah,
of course ketones are in millimole, blood ketones. So if you're popping like a 4 on the blood ketones, which is a really robust
that's
amount of,
high.
yes. Oh, I've had as high as when I've been fasting, Ben, I've had as high as like 7.6. It's been
That
really,
has to have been, and that was multi-day, right?
Oh, you know I do long fasts. So.
Yeah, okay. Because the longest I've ever fasted is 48 hours, and I got like the high ones